we're going to handle linear motion. And we have a sample question here. The question reads, two policemen were together at a road junction. Each had a walkie-talkie. The maximum distance at which one could communicate with the other was 2.5 kilometers. One of the policemen walked due east at 3.2 kilometers per hour, while the other walked due north at 2.4 kilometers per hour. The policeman who headed east traveled for X kilometers, while the one who headed north traveled for Y kilometers before they were unable to communicate. We are required to draw a sketch to represent the relative positions of the policemen. In number 2, from the information we have acquired from one above, we are supposed to form two simultaneous equations in X and Y, and then find the values of X and Y, and lastly, calculate the time taken before the policemen were unable to communicate. The question is simple and is done as follows. So first, you're going to draw a sketch to represent the relative positions of the policemen. And this is a sketch. So one walked due north. Let's say this is our starting point. Our starting point is here. So one walked due north. This is due north. And the other walked due east. This is due east. Yes. So again, it's a question. Two policemen are together at road junction. So a road junction is here. We're told the maximum distance at which one could communicate with the other was 2.5 kilometers. One of the policemen walked due east at 3.2 kilometers per hour. So the one who walked due east was moving at a speed of 3.2 kilometers per hour, while the other who walked due north was traveling at a distance of 2.4 kilometers. 2.4 kilometers per hour. And again, we told the policeman who headed east traveled for X kilometers. So the one who headed east traveled for X kilometers, while the one who headed north traveled for Y kilometers. And lastly, we told the maximum distance at which one could communicate with the other was 2.5 kilometers. So let's say the maximum distance was here before the devices no longer worked. So it was 2.5 kilometers. 2.5 kilometers. So we told draw a sketch to represent the relative position of the policeman. I think we're done. That's a sketch. And number 2, you told to form two simultaneous equations. So our first equation is, how do you calculate distance? Under linear motion, distance is given as speed times time. Therefore, when we want to find time, our formula will change and it becomes distance over speed. So for the policeman who headed east, time east, it will be distance for the one who headed east, which was X kilometers, over time for the one who headed over speed of the one who headed east, which was 3.2 kilometers per hour. So our time for the one who headed east was x over 3.2 hours. And again, time for the one headed north was equivalent to distance covered, which was 5 kilometers, over speed of the one headed north, which was 2.4 kilometers per hour. Meaning, our time for the one headed north was y over 24 hours. But remember, it's time the policemen started working at the same time. So it means when they stopped, when the devices stopped working, the duration was the same. So time east was equivalent to time north. So x over 3.2 was equivalent to y over 2.4, and that forms our first equation. Good. Our second equation, we told the maximum distance between the two policemen when the walkie-talkie stopped to work was 2.5 kilometers. So it means from Pythagoras theorem, x squared plus y squared is supposed to give us 2.5 squared, and that gives x squared plus y squared was equivalent to 6.25. That's our second equation. So you're done with the first part of the question. The second part, find the values of x and y. So I have our two equations here. So the values of x and y, we shall calculate the values of x and y. So we say x over 3.2 was equivalent to y over 2.4. That was the first equation. So we make some modifications of the first equation. Let's do a cross multiplication. So 2.4x was equivalent to 3.2y. Good. Over 2.4 over 2.4. So our x was equivalent to 4 over 3y. Good. Our second equation, red. So this part of the equation, this 2 Roman 1, you're doing 2 Roman 2. Y squared plus x squared was equivalent to 6.25. But our x is equivalent to 4 over 3y. Therefore, our x squared is equivalent to 4 over 3y squared, which will give us 4 squared is 16, 3 squared is 9, and if we square y, the answer is y squared. Hence, y squared plus, instead of putting x squared, we replace it with 16 over 9 y squared is equivalent to 6.25. This over 1 over 1. Our LCM in this case is 9. So let's multiply all through by LCM, which is 9, and that will give us y squared is equal to y squared 9y squared that's y squared times 9, plus 16 over 9 y squared times 9, which is 16 y squared, is equivalent to 6.25 times 9. So 9y squared plus 16y squared was equivalent to 6 times 9, and that gives 56.25. Like terms, 9y squared plus 16y squared is 25y squared, which gives us 56.25. So if we want to find the value of x, the value of y in this case, we're talking of the square root of 56 point. No, I'm sorry. We want to find the value of y squared, so we shall divide both through over 25 over 25. So forget about the square root thing. And this will give us y squared was equivalent to 56.25 divided by 2.5. Divided by 25. 56.25 divided by 25. And that will give us 2.25. So this stage we shall find the square root of y squared, and the square root of a positive number is plus or negative 1.5, square root of 2.25. And since you're doing it measurement, our value of y will be positive 1.5. Ignore negative 1.5 since you're doing it measurement. Dealing with measurement. So you have a value of y. Let's find out the value of x. The value of x was equal to 4 over 3y, and that will give us 4 over 3 times y is 1.5. And the answer in this case is 1.5 times 4, which gives us 6, divided by 3. The answer is 2. I think we learned the second part of the quiz. And lastly, Roman number 3, question 2. Calculate the time taken before the policemen were unable to communicate. Time taken. Roman 3. Question 2. Roman 3. So time taken we can use any. It can be time of the policeman who headed east, which is also the same as time of the policeman who headed north. So let's use time of the policeman who headed east. You give us time of the policeman who headed east, east, time, east, x over 3.2 hours. But we have our x was equivalent to 2 over 3.2. Our x is equivalent to 2 over 3.2, and whatever you have is in terms of hours. So it's 2 divided by 3.2, 0.625 hours, which can be converted into minutes, and it gives us, or 37 minutes and 30 seconds. You can also confirm by using the time note. It's just a confirmation. The answer will be the same. Time note was equivalent to y kilometers, y over 2.4 hours, y over 2.4 hours. So our y is given as our y is given as 1.5 positive 1.5 over 2.4. That will give us 1.5 divided by 2.4. So you can confirm all of us the answer is the same, hours, which we said the same as 37 minutes 30 seconds. So our last part of the question, calculate the time taken before the policemen were unable to communicate, is therefore time taken was equivalent to 37 minutes and 30 seconds. I think we're done. I hope I was of help. Shalom. Till next time. Thank you.